more problems using Bresenham's method, and we'll see the effect of Bresenham's, how these floating point operations are not used here, and how the lines are drawn with the help of this algorithm, right? Try to solve by yourself, right? As we've already discussed about, let me first page on my screen. I hope my screen is visible. Can somebody let me know? Okay, okay. Actually, I'm having some throat infection. So, yeah, this case, m greater than 1, right? Slope is greater than 1. So, in this case, we have to calculate first the base case that we all know. I mean, that decision parameter, which is nothing but d here. So, the base is nothing but 2 del x minus del y. However, in case of m less than 1, it was 2 del y minus del x, if you remember. As in this case, m is greater than 1. So, if m is greater than 1 means del y by del x is greater than 1, right? Del y by del x is greater than 1. So that means del y is greater than del x. So then now the question is that in which axis you will apply sampling, right? In which axis you will apply sampling? I mean, which axis will be incremented at unit intervals? Who can say? Which axis? Okay. Yeah, Pransu, Nitin, and Subham has written y axis, right? Absolutely correct. Thank you all. So we will increase the value of the y, but in the previous case, I mean, when where m is less than 1, we are increasing the x value by 1, and then we are calculating the y value, whether yi or yi plus 1. Similarly, here we will increase the value of the y all the time, which is nothing but yi plus 1, and then we will choose the pixel, whether it is xi or xi plus 1 based on the conditions, right? So if you look at the condition here, if di is less than 0, then you have to plot the pixel xi yi plus 1, right? If and at this and for that particular condition, the di plus 1, the next d value will be di plus 2 del x, please remember, right? So similarly, if the case is di greater than equal to 0, then you have to plot xi plus 1 as well as yi plus 1, right? So d of I plus 1 is equal to di plus 2 del x minus 2 del y, right? So this is what is the decision, you can say, variable value for the next iteration, for the next step, you can say I plus 1 step. If you know the value for d1, so you can calculate the value for d2, and accordingly you will plot the pixels, right? So we have solved a problem in our previous class. Uh, we have solved a problem for a particular case where m is less than 1, right? So today we will solve a problem where m is greater than 1, right? Just a minute, Kali. Add a few things. Class 0. Just a second. I'm trying to add few pages, blank pages. Yeah, let me write the points, right? T10, 26, 18. These are the 2 points which are given, and you have to find out the in between points, addressable pixels in between these 2 points. So, first point, I mean, this is the starting point, this is the ending point. So, now, as we have seen, that we have to calculate the m value first, right? And then accordingly, we will calculate the d1 value. And once you got the d1 value, then you have to calculate rest of the other d1 value, and accordingly you will plot the pixels, right? So del x here in this case is nothing but 6, right? And del y in this case is nothing but 8. What is m here? M is equal to 8 by 6, which is greater than 1. So this is the case where m is greater than 1, right? If m is greater than 1, then d1 is equal to 2 del x minus del y, if you remember, right? So what is 2 del x is 12. So 12 minus 8 is equal to 4, right? So now we have to find out the pixel points in between these 2 points based on this d1 value, and you know how to calculate it, right? So try to find out all the values I, let's say di, let's say x comma y, the pixel value. The pixel values are either xi, yi plus 1. Y value will always increase by 1 because del y is greater than del x, or as xi plus 1 yi plus 1. It's a fast question. Let's try to solve. Let's solve a simple one. 0 0 to let's say 6 10. ये दोनों सॉल्व करो. Initial point 20. D1 is equal to 4, which is greater than 0. If it is greater than 0, if you remember, both values will be increased. That means it will be 21 11. Right? D2 will be calculated using this formula. This formula. Because it is the greater than case, right? So di plus 2 del x minus 2 del y. That means d1 plus 2 del x minus del y. So what is 2 del x minus 2 del y? 2 del x is 12 minus del y. 2 del y is 16. It is minus 4, right? So this term will be always minus 4. So 4 minus 4 is 0, right? If it is 0, that means the else part, if you remember, then both the value will be increased by 1. Then similarly, you calculate the value or you calculate the other pixel positions from 2010 to 2618. Then you solve this one. Try to solve these two problems today. Solve problem. I can pick up randomly I mean, any one from you and will ask the points directly. Right? Take your time, 15-20 minutes I'm giving to you. Solve both the problems, then I will pick up randomly some of you and ask the points to write down in the chat box, or you can also unmute your mic and tell us the points. Then we'll verify with others. Try to solve it using pen and paper. Yeah, second question. Okay, this one. So Ansu Nitin, let me choose Aditya Anurag. Okay, Anurag, are you there? Anurag Jain.
Yes, sir.
So Anurag will tell us the points. I mean,
Yes.
after 22 and 12, what are the points? And Pransu, just verify with your answer. Okay?
Okay, sir.
22,
Anurag,
12,
please. Then
22, 13.
22, 13. Let us verify with all. Pransu, are you agreeing with this?
Yes, sir.
Okay, Anurag.
23,
Continue.
14.
23,
Yes, sir.
14.
24,
Okay, then 24.
15.
Very nice. Good. Pransu,
Yes, sir.
then
25, 16.
Yes, sir.
okay. Then
25,
next 25,
17.
Yes, sir.
17.
26,
Okay.
18.
26, 18. Fine.
Yes, sir.
So that means we have reached from 2010 to 2618. Okay, so how many of you have solved the second problem? So I think this is the correct answer, right? This is the correct answer. If anyone is getting other pixel values rather than this, then that is not correct. So I think all of you have got this one, right? Okay, Anurag, thank you. Then have you solved the second problem? Have you solved the second problem? Sir, done. Okay. Yeah. Priyanka, are you there? Priyanka Kumari. Priyanka, are you there? Pransu, am I audible?
Yes, sir.
Okay. I think she is not there, Priyanka. But her name is showing in my list. Okay. Sonal, are you there? Sonal Agrawal. Sonal Agrawal. अरे ये लोग है कि चले गए कहीं? Pransu.
Maybe here only, sir. Maybe they might be.
Yes, sir.
Sonal, have you solved the second problem?
Yes, sir.
Then Sonal will tell us the points. This Priya will verify.
Okay, sir. 0, 0.
Okay, just a second. Just a second. 0, 0 to 610. So first point is 0, 0, of course. Then next point.
Second, 1, 1.
This Priya is there. This Priya.
Yes, sir.
You verify.
Yes, sir. 1-1.
0, 0.
1, 1.
Hmm.
Hello.
Then next. Continue.
1, 2.
And to this Priya verify.
Yes, sir. Yes, sir.
2, 3.
2,
2, 4.
3. 2, 4.
3, 5. 4 6
3 5 4
4
6
6
uh,
4 7 5
4
8
4 7. The next is
5
5 8.
8 5 9
Okay.
6 10
6 10. Oh. Despida, you verify?
Yes, sir. Correct.
Yeah. I think this is the correct answer.
Yes, sir.
Sure. Thank you, both of you. So now let's Despida. Okay.
Thank you.
So we have seen 2-3 examples of line drawing, right? Given 2 endpoints or 2 confined points using Bressenham, using DDA, using simple calculation method, I think direct calculation method. We have seen the limitations of direct calculations, limitations of DDA, advantages of Bressenham's line drawing algorithm. If you draw these lines in the raster screen, then you will see again there will be some effect, right? Steering case effect, and we call it jagging, right? So that will be there always. But yes, this algorithm tries to reduce the effect of the jagging and staircase compared to others. So these are all the advantages, of course, because it only uses integer calculations, right? So and it is also called as fast incremental algorithm and effective algorithm for line drawing, right? So in the next class we'll be discussing about circle generating algorithms, how we will generate the circles like we generate the lines, because circles and lines are so important to draw complex figures or complex pictures, right? So with the help of these lines also you can draw so many complex pictures. And similarly also yeah, there is a need of drawing circles and some ellipse as well, ellipse circles, and we'll see it's a special case of core circle. So we'll see that how then what are the different algorithms are there to draw the circles and ellipse. Okay, so thank you all. I have a good day.